Hi everyone, welcome back to this channel. In this video I'm going to continue on with the PROPSIM setup, and today we're going to focus on how to generate a satellite path using the GCM software from PROPSIM. So as you can see here on the screen, this is something that I've created. So we're going to go back to default and we're going to show you a couple of ways to create the satellite path for you to load into the PROPSIM so they can emulate out the communications between satellite and your mobile station. So let's get into it. So this is a GCM software. Let's create a new project, and from here we go to satellite. So under satellite, there are a few options here. So NGSO is a non-geostationary orbital. These are options for you to choose when your satellite is not stationary, like in the LEO or MEO orbit. And GSO is a geostationary type of satellite emulations that you can set up. And then we have advanced. If you know all the parameters about the satellite that you want to emulate, you can use this. So the last one is TLE file, is a 2-line elements file, which you can download from the internet for the latest orbit, and you can use that information to emulate the trajectory of that satellite versus your receiver on the ground. So let's get into it one by one. So let's look at non-geostationary orbital. What you can do here, so setting out the altitude value, the initial angle, the final angle on the globe, and these are your mobile stations. So one thing to be aware of is that I haven't found a way to preset the location of your receiver for this setup, non-geostationary orbital. So let's have a quick look right now. Let's type in the file name so that we can save it. So click OK. So by default, it was set at the 0, 0 locations. You can still change some of the parameter, like number of satellites, the altitude. So the lower the altitude is, the faster the velocity will be. And if you increase it to 1005, you can see that the velocity is a bit slower. So this is just part of the things that you can play around. And then elevations is where you're going to set how far it's going to travel on the globe. Like for example, we set it 0, then we click apply. We start from here to 160. Then you can change all this trajectory as you wish. So let's say we set it to 45, and then we click apply. So it's a bit smaller, so we can set it to 120. So it's quite close to the receiver. It's still a long period of movement, so you can actually zoom in if you want to. That's one way to do it. So frequency uplink, downlink is where you're going to have the input to the PROPSIM and output from the PROPSIM. So this is where you can set it, and you can click save and generate the channel modeling. So this is how it looks like. The path loss, power delay profile, it's almost the same. It's not so much of things that we change. And then channel modeling, this is where you can change some of the channel modeling. Here you can go with some of the pre-installed, so it's up to you. We can click apply, we can generate the emulations, then we can load it to the PROPSIM. So once we've done that, we can close it. But one thing I want to do is I want to reduce down the traveling time so that we can save some emulation time. So what we can do is we double click on any of the part of the screen, then we can go to the satellite scenario setting. So we can't change the time here, but we can change the elevations. So let's change it to 100, and let's start somewhere higher. It will reduce significantly on the emulation time here. Let's try another one, 85 to 95. Save, and we can go straight to channel modeling emulations. Okay, it's done, it's ready. So this is the PROPSIM, and I'm going to run the emulations. I'm going to open it right now. So let's go to the one that we just set, is NGSO trial, and let's run the simulations. Yes, as you can see, this is the exact same one that we just generated, and then we can just load and run. So this is as simple as that for non-geostationary. So these are the parameters you can set up. I won't go through that, and just let it run for a while. And you can see that there are changes of this power profile because we did add in some standard ITU channel modeling. So that's the first part. Let's go into the second part. So let's try to create a geostationary type satellite, and what are the parameters that you can play around. So you go to satellite, geostationary, orbital, these are longitude. Let's say we set it to 167, which is to the eastern side. Inclinations, this where you can check with ChatGPT or any help online to tell you more about what's inclinations. So let's say we set it to a 40 degree. And this is where we're going to put in. So this is a bit tricky because you want to make sure that your mobile station is part of the path of the satellite. Let's say latitude is set to 37, minus 37, and longitude 166. Altitude maybe 10 meters from the sea level, ground minus 37.5. It's a bit different from mobile stations. Longitude 166, altitude we set to 20 meters. Let's save it. So GCM, geostationary, trial, today's date. Then we click OK. So you create a new path. So you can see it doesn't make sense here, but this is just a proof of concept, just to show you how it can be done. So you can change the inclination here, 40 degree, you can change it to a maximum 90 degree, which it goes over the polar side. So let's say we set it to 30 degree, you see that the figure of 8 will be a bit smaller. So we set it to 40, because that's what I tried and it works. And the second thing about this is that if we let the PROPSIM to emulate out the whole path, it's actually wasting quite a lot of time here, because this is a part that you want to focus on. So you can actually change here, orbital durations, look at the model preview, and then you can decide the start and stop time to determine where is the closest to your mobile station. So 59,000 to about 68,000. So we can cancel that. So we can change here. It's actually inside this model preview. So 60,000 to about 68,000. So this is where we want to change that. 60,000 to 68,000. Then we click apply, and then we should see a flat line somewhere here, which is what we want, because that's where the signal is strongest to the receiver. So we click apply, and it will shorten down to this part. So when you generate these channel emulations and then dump it to PROPSIM, it will just focus on this part. So the same, you can change the location again, and then you can change the uplink and downlink frequency, save it, and then you can change some of the parameters like the channel modeling over here as you want. So we can change this S band, that's it, apply, then we generate the emulations, we compile it, then we can dump it to PROPSIM. So once it's done, and let's click OK, close. Let's go back to PROPSIM. So we can stop the emulations, and then we open the new emulations. So, oh, I haven't generated it. I haven't built. Okay, let me build it. Alright. Build emulations done. So build emulations done, and so let's browse. I couldn't find that. My emulations, GSO trial SMU. Yes. So you can see that the figure of 8 satellites. So this is one that we want to see, and yeah, just load in PROPSIM and let it run. And this is a channel modeling that we have added in, and it's over 8,000 seconds. If you remember, we did set the time between here to here instead of running through the whole 80,000 points. Okay, that's the second. Let's try the third. So these are third options for satellite. You can go with advanced. So these are the standard parameters if you are familiar with how satellite propagates, and these are the things that you can change. So what does each parameter here means? So I can have a quick check with the AI. So here are the some parameters that being used in setting out a satellite propagations. So these are the things that you can check online. I'm using an AI semi-major axis, so the size of the orbit, eccentricity, how stretched circular the orbit is, and we have argument of periapsis, where the closest point within the orbital plane because it's ellipse type orbit. And then we have RAN, the orientation of the orbital plane relative to Earth equator, inclinations. So these are the things that you can play around to set that up. And I did a quick one. Let's do this. Eccentricity is between 0 and 1 or more than 1. Let's try 0.5, and then it's between 1 and 0.1. So let's say 0.05. Argument of periapsis, it's between degree, so we are looking at about 10. RAN 5. So you can play around with these informations and see is that what you want. And again, I'm not an expert for this, I just know how to use this, that's about it. So you can set the time, how you want it to be, the starting time, and then the durations. For now, we just set it to 10,000 maximum points. And to save your hassle, you just click here, place in the mid of orbit, and then we save this. GCM satellite advance. Okay. Yes, so you see that I created a path for the satellite and my receiver will be in the path. So it takes some time to generate it out based on what you have keyed in. Just wait for a while. So this is what we have, and you can see that it does pass by here, and you can just set the time, start stop. You can play around with it, and chances are this is going through. We are looking about the mid range, 2500 to about 5000. Let's give it a try. Yeah, somewhere there. So we start from 5000. We stop about 5002. Yeah, somewhere there. So 4800, apply. Yeah, so you get the gist how to set it up, and once you click save, it's the same thing. You can focus on here, or you can run for the 24 hours as you go. And if you want to change anything here, you can just click that MS and then change the modeling here. And then we generate, and then we build, and then we load it up to the PROPSIM. So you can see that the receiving part quite high in the middle because that's the path that it went through. So now we rebuild the emulations. So once we've done that, let's load it from the PROPSIM. So we go to emulations, open, and look for that. So it's GCM satellite advance, not this one, satellite GCM satellite advance. It's not here again. Let's go to browse, emulation, satellite advance. Yes, so you can see that it does pass by, and this is a profile. You can start running or not, it's up to you. So let's go to the fourth way to set up a satellite trajectory path. So let's close this. Let's create the last one, TLE, 2 lines element. So we go to satellite and TLE. So TLE file, this where you can download and create .tle file and then recall from here. So how does the TLE file looks like? I can show you here. So this is the 2 lines informations, which consists of the day, the week of the year, locations, things like that. In more detail, you can actually check online, and there are multiple ways to get this TLE informations. One of it is to go to websites such as this, not the AI, such as this, and to yo.com, and just type in the satellite that you want to emulate. Then you copy this TLE to here, number 1, copy, paste into a notepad and save it as .tle file, and you can recall it from the GCM. That's one way. And the other one is to go to ChatGPT or any AI, type in, and exactly the same. Copy, paste to the notepad and save it as .tle file. So once you have that, you can change the durations, but I will just leave it as it is, and then I click midpoint and let's say GCM, TLE, trial. So once you've done that, let's look at the graph. So the satellite on top of the receiver. So you see the red dot there is the path that it crosses. This is the durations. I don't really change that. That's it. Just click apply and save and generate it if you want as it is. Doesn't need any ITU tile modeling, so you can just put that and generate the emulations, and then we can recall it from the PROPSIM. Okay, it's ready, and let's go to PROPSIM. So let's go to emulations, open, browse, TLE trial emulations. So just run, and there we go. It's as simple as that. So this is quite a short path. So this is the path we created, and we just wait for it to go through. This is 10,000 points though. But anyway, you get the gist. How can we design a satellite trajectory based on 4 different kind of setup in GCM. So thank you for your time. Thanks for watching.